Hey, so welcome to my talk. I'm going to try and speak slow because I'm very nervous. So I'm going to give my talk on about building my ultimate home lab. My take on ultimate might be a little bit different from what you think of. So hopefully my key takeaways from this talk is if you haven't got a home lab, maybe you'll want to build what you're on, just get started, it's easy. Or, if you do have one, maybe you'll think about how you're doing your home lab, maybe you want to change it, see if you get somewhere. So a bit about me, or who am I? I saw it in the talk once, so I really wanted to do it. I'm a security engineer for an insurance firm. I've been a SOC analyst and a detection engineer previously. Big advocate, obviously, for having a home lab. I think it's a really great tool to learn with, and also attributed to being able to progress to my different roles quickly in my career. Because I was able to learn new technology before they were implemented in the organisation I work for. Dog person, not cat person. So what is my ultimate? So my ultimate is something that is cost effective and also flexible. So I want it to be able to do what I want it to do easily, be able to access it easily, compact. So I don't want a big server rack in my office, which is quite small. I want something that I could probably put in the cupboard once I'm done with it. So it's to test the what ifs. So one of the main things I like doing in my home lab is what if we didn't have AV or detection engines stopping malware at stage 1? What if the malware got all the way through, it executed all of it, what it wanted to do, and how does that look in the log telemetry? That's what I'm most interested in, seeing what the log telemetry looks like with no restriction on execution. I don't really want a second job, so I want a low maintenance to no maintenance lab. So I don't really care if it's got vulnerabilities, and think about it in such a way. And also focused on what I want to test. I don't want lots of unnecessary bloat, lots of other things I have to maintain, or, I really want to test this thing, but I need to fix my DC first and get authentication working. Yeah, I just want it to be really focused, really streamlined. I'll go more into it, but I only really install things or set it up in a way I want to do when I go to test or try and simulate something. So I think the first thing you should do is probably setting your lab's goal. So having a goal, again, helps with focus, being able to really streamline what you want to do, avoiding that second job syndrome. Do you want to try it? So some sort of goals you can have. So do you want to try new software? Maybe you've got a job interview coming up, etc., and they're using a particular software, a particular SIEM solution that you've never touched before. Most of these vendors have a trial or a free trial you can get access to. It's a really good way to say, no, I've not used that software, but I know what it looks like, I know how it feels, and I use this software, and it's all very similar, because if you use one SIEM, you've probably used, queries, languages, how to build queries. You're going to be able to use most SIEMs within a couple of days. See what attacks look like. Maybe you want to see what attacks look like from a defender and attacker standpoint. So, think about your purple team in there. So you really want to run for your attack and then, okay, so what does that look like from the defense standpoints? And me myself, I'm very defense focused. So I don't often see what the attacker has to do to execute something. I just see what it looks like in your process command line, and obviously I know what you wrote to do that, but yeah. Again, play with software, I'm not going to industry, I've always said that. Cool. So the first step is probably your hardware choices. So what kind of hardware do you want? While it looks really cool in posts online, I'd probably recommend avoiding servers. You don't want a power-hungry fan-spinning machine in your office or anywhere in your house, really, especially if you're not going to pay any electricity bills. I've come from a networking background, so I really wanted a switch that has some VLAN and some port mirror capabilities. You tend to probably have to look at business class switches for that, but you can get them pretty cheap if you want to look at Netgear. Well, I wouldn't recommend them in a production environment. They're pretty good in a home lab scenario. I think obvious one here, you're going to probably be buying second hand. You don't care about if the hardware fails or if you don't want to get ripped off, but you don't really care about your availability of your hardware because it's a lab. So Facebook, eBay, old stuff. You want to be careful not to go too old. Otherwise, again, you have like power issues and just you want to be able to run some stuff. One thing I've heard before, which I think is really good, is old laptops. Even if the screen's broken, it's great because it's a server with a built-in UPS. Don't underestimate the cost of RAM. RAM is crazy expensive for some weird reason, I don't know. And also old hardware as well. People seem to think 10-year-old hardware can still fetch crazy amounts of money. So just be wary of people really just appreciating how old the hardware is. You may want to think about stuff like NICs, so you want additional network ports in a single PC or multiple PCs, you want to switch, RAM, etc. So that's what you can think about your hardware. Software. So you're probably going to want some sort of virtualization unless you've got servers coming out your ears. So VMware, I think that's kind of like dying off. Proxmox is kind of like the way to go, I think, in most scenarios. It's really feature rich. You could probably spend a day on just installing Proxmox. And for anyone who's not familiar with that, it's on-the-box virtualization, so type 0, I think. And then obviously Docker containerization is really great for saving resources. If you've got multiple things you want to run, recommend going with containerization. If you want segmentation still, you're going to save a lot of resources in running big VMs. Windows or Linux, you're probably going to want both. Firewall, really, I think the most people tend to lean towards OpenSense or pfSense. So really, really feature-rich firewall with lots of modules. I think that's the way to go. There's definitely probably other options out there, but that's what I'd recommend. Windows servers, so think if your lab is expendable, I just want to mention that. You can get eval license for most Windows licenses, so it's a really good way to get a licensed server if you want to have licensed servers. You want a SIEM. So again, I come from a detection background. I am currently a SIEM engineer, so my lab obviously has a SIEM. You may not want a SIEM in your lab because that's not what you're interested in. Maybe you just want to attack and attack and attack. But I want to see what the telemetry looks like. So I wanted a SIEM solution, chose Elastic. It's great SIEM for easy, it's quite free compared to other SIEMs. So with like Splunk or something, you get on your trial license, you get limited on gigabytes. You're not limited in the same way you are with Elastic. They do have some premium features, but it's very easy to activate a trial license. So set a snapshot, activate a trial license, 30 days, just roll it back. So you want some way to collect your telemetry, so you're going to look at stuff like Sysmon, hopefully stuff you're maybe using in your production networks. You probably want to use in your lab. It really allows the playground there. So, yeah, telemetry, so you probably look at stuff like Sysmon, EDR tools. There's a few free ones out there. Elastic also comes with a EDR capability, which collects some really useful network technology. So while EDR is very expensive, you could use something like Elastic and see what kind of capabilities you're going to get from a commercial grade EDR. Again, so maybe you don't want to create your own data, maybe you want to import data, so you've got like malware samples, network captures, and then also Atomic Red Team is great if you want to just run Atomic or I can't remember the command and see what all the atomics look like in your environment and upset your computers. Again, there is also loads of pre-built platforms and many projects out there, maybe people much smarter than me, such like SoftElk and Helk, which are really great, and I would recommend checking them out. I would say you want to try building stuff, I think, on your own at first to understand the building blocks, but once you're comfortable with the building blocks and understand how that always links in, really check out them projects and gets you a head start. So deploying, so when you've got your hardware, you've got your software, you've made your software choices, you've got your goal, you want to probably then look into deploying it. So I would setting up automation to deploy is great. I'd always recommend knowing what your automation is doing. Don't just search for scripts on GitHub and then run them. Actually read through your Ansible scripts. Because when things break and you're not sure why, knowing what should have ran and seeing why there's knowing why it's failing makes it much easier. Maybe make your own Ansible scripts, make them open source, let other people have a go. Before maybe like doing anything, set some VMware snapshots, really lowering that maintenance you need to do to recover from playing in your playground is set a snapshot, and then you can roll back. Really simple stuff, but I've forgotten it. I'm sure someone else will. So what file rules do you want to put in place? One thing I really like to do is keep my lab really segregated, so I block all outbound access. So if I do make a mistake and put something malware on there, maybe have the worm capability, it's not going to get out onto my home laptop and upset my work PC. Install trial licenses. You really want to use the premium features. Vendors hide all the best features behind the paywall. So if they are a decent vendor, hopefully it's really easy to access their trial and you don't have to contact sales. And a lot of vendors do give like development licenses if you purchase their product from your commercial environment. So that's always something worth speaking with your vendors about. Seeing what your lab normal is. So how do things normally run? This is again a detection focus here. So seeing like what logs should I expect to come in? Can I filter them out? Reduce the costs. One of the big costs will probably be storage along with RAM. And then do you want to monitor things? Do you really care at 3 a.m. if your lab is no longer working? So think hard about if you really care about monitoring. I take the approach of not really to monitor anything. If it breaks, I'll just reinstall it. That's my lab. Very simple. Didn't do this before the talk or today at any point, promise. So again, just have a laptop, actually have a Chromebook to give you the shivers. I just RDP or HTTPS to a portal that's exposed on the Proxmox VM, which is then running an Elastic instance. So on the Proxmox, I tend to run a DC, a Windows client, and then a Linux server. The Linux server will run all the development, all the Blue Team side of stuff in terms of Elastic, any Logstash, any additional parsing I want to do. The client will have an EDR installed and be domain joined. Then you attack it, whatever attack you want to do. In my instance, so maybe deploying some ransomware, seeing how that looks from through a SIEM solution is quite interesting, especially when majority of ransomwares tend to be blocked quite early these days in terms of AV and MDE will kill it as soon as the file drops. So turning off MDE and then running it, seeing the log telemetry is really interesting, seeing encryption all the files. What does that look like? Again, so with a NIC, you've got multiple ports, so I like to actually have, rather than doing it all virtually, I like to have some physical things I can unplug and cut and hit if it's not working. So I like to have a port switch where I can do port mirroring on and then link that back. So it looks like a bit like a loop, like the computer's talking to itself, but because we have different NICs assigned to different VMs, it's really different VMs talking to each other. There's some final points. I really like this saying, cattle not pets. So really think of your lab as cattle, not pets. Don't get attached to something. Don't be afraid of just deleting it or reinstalling, starting fresh. If you've done things right and got your Ansible scripts and such, it's really quick to reset up. So don't get attached. Don't try and fix something that you don't know why it's broken or some malware screwed up. It's not worth the time. I'd always say probably try and start small and build out. Start with a small goal and build out. You don't need to build the best and the greatest and the most powerful lab that you can have before you start doing much learning you can do. You can do many learnings by just having a very simple single PC, single laptop, and just installing software. Especially if you want to be like a systems administrator or a security engineer, just installing a SIEM solution can be a really great head start. You could all do it. So you could do it all in the cloud if you really, really want to. I don't know how big your wallet is, and also there's a problem where it always has to be on the internet if you are in the cloud, which is a thing to think about, because you're going to have to access it somehow. Keep labbing labs is, so I want to tell you a story here. I had a colleague of mine at one of my previous companies. He had a home lab that became his home network, and he had to have a maintenance windows with his partner to bring down the lab to do maintenance. I really do not think that's a good idea, and you should keep your lab labbed. I keep mine specifically not running my home network or touching my home network in any way, because I want to do detection stuff in my lab, so I want to deploy malware. Got to be a little bit responsible with that. But you know, if you're going to run like I don't know, some sort of file server or something, I don't think that's labbing at that point. I think that's running a service for your house. So I'd keep that separated from labbing, in my opinion. A lab is a playground and should be gated as such. Try not to get lab envy. You can go on like subreddits and online and see people's with like 5 servers, and just try not to be jealous on how they've afforded that and the budgets people seem to have on spend on their labs. I have other priorities. So try not to get lab envy, and just remember they're probably spending £500 a day in electricity. And then I think one final point is a little bit of a negative, so a bit of a shame to probably end on it. I've rushed through my slides. But labs do have their limits, and understanding what their limits are. So from a detection standpoint, one of the biggest limits is access to vast amounts of data. You're probably going to find it very difficult to generate about a terabyte of data, over a terabyte of data a day, and good quality data. And you also don't have developers doing weird stuff in your environment for you to test against. So they do have their limits, but I think the positives and the learns you can gain from them vastly outweigh that. Questions?
Any questions? You got a picture of your lab?
No, it's in the cupboard. I recently moved house, so it's not actually turned on at the moment, sorry. But if you wanted to know a picture, it looks like that PC there, literally with a switch on top of it. Very simple. So I think it's a Dell Optiplex. That's one thing I did forget to mention. Like Dell, I think small form factors PC, if you go too small, you tend to get like the price problem where things get really expensive because it's really small. Too large, you've got something big and heavy, so sort of medium-sized PC is the best.
Cool. Awesome.
Thank you very much.